Question 3 asks, when should the t-distribution be used to find a confidence interval for the mean? So for confidence intervals, we have two choices. We can use a z-distribution or a t-distribution. And there is one piece of information that determines whether I use a z-distribution or a t-distribution. This is true for confidence intervals. This is also true for hypothesis testing when you're doing some kind of hypothesis test. If you don't remember this, if you can't memorize this, if you look at the formula sheet, there's a way to tell from the formula sheet. So we'll look at Chapter 7, Confidence Intervals and Sample Size. So there's the z confidence interval for means. There's the formula for it. X bar minus z alpha over 2 times sigma over the square root of n. It's less than the mean, which is also less than x bar plus z alpha over 2 times sigma over the square root of n. This is a z confidence interval. And the next is a t confidence interval. So if you're looking for differences here, right? The z confidence interval, of course, uses the z alpha over 2 values. T confidence interval, of course, uses the t alpha over 2 values. So you're using different tables to get that information. But the other difference is, for the z confidence interval, we use sigma. The population standard deviation. Population standard deviation. T confidence interval, we use S, sample standard deviation. That's the difference. For the z distribution, sigma is known. And when I say sigma, I'm referring to the population standard deviation. And that will be given to you in the problem. If you're not given sigma, if you're not given the population standard deviation, then sigma is unknown or sigma is not known, and you're using a t-distribution. If you know the population standard deviation, z-distribution all the way. If you do not know the population standard deviation, t-distribution all the way.